Hello, welcome back. Well, immediately after that last video I painted these two remaining healthy sheets of polystyrene that I had to try and avoid any problems with the UV exposure. This was kind of a pain in the ass actually, because the enamel that I was painting with is actually quite thick and it spreads kind of like honey. I didn't actually notice this when I was doing smaller jobs. When you're doing something as big as this, it just seems to take forever. And I had to do this mostly in the dark, or almost in the dark, because I didn't want moths and mosquitoes and bugs and everything coming down and landing on it. So I turned the lights off, so I had to wait until it was after dark to start. And I turned the lights off and I used a little head-mounted flashlight on a very, very low setting to get this done. But I think it was worth it, because even though I've been keeping them out of the sunlight for the most part to be on the safe side, everything so far with these sheets has turned out perfectly fine. I didn't like that lumpy nose cone that I made from fiberglass, so I decided to make another one, this time just cutting the edges straight. And instead of using fiberglass, I got hold of some of this Minwax polyacrylic stuff that I've seen people using on YouTube, and that's pretty good actually. And I decided to just try covering it with paper, just ordinary copy paper for my printer, which seems to be the best. I've done plenty of experiments on this in the last few weeks, and it turns out, from what I can tell, the best so far. I'm just about to paint this nose piece now, but I thought I might show you what it looks like with the paper and polyacrylic on there before I do that. So I put one sheet going that way and two sheets going over that way. And with two sheets it feels fairly good, like you can't press your finger into it anywhere near as much as you could originally. And I found that if you're very gentle and you sand going away from the edge of the paper like that, you can get it to sort of blend. You sort of use the sandpaper to cut the paper off there, and it blends quite nicely into a smooth edge. Unfortunately, I found that it doesn't go so well on the flat areas. I thought I might try and sand out this little bump here, but it's kind of lifted the edge. Once you get this edge of paper like that, you can't really sand it anymore. It just starts to lift up, so I stopped at that point. But yeah, I'm quite pleased with how this turned out. So I'm actually thinking I might try making a whole plane out of this, well, a wing at least, with using this method, this kind of poor man's fiberglass. It's gives a pretty nice result, sort of nice and smooth and waterproof finish. So we'll see how that goes maybe. As things got closer to the final configuration, I began to realize that my CG problems were not over by any stretch. So at first I went berserk on the tail, just shaving and drilling and cutting away any little bit of material that wasn't really necessary, but even that was not enough. So what I had to do was change the configuration of how the wing mounts onto the fuselage and move the entire wing back 4 centimeters. And in fact, I would have not had to move it quite so much if it wasn't for the fact that the wing itself is quite heavy relative to the fuselage. So the wings together weigh almost twice as much as the fuselage, because they've got the motors on the wings. So even though you're moving the wings back a little bit, you're taking a lot of weight. That you're moving the heaviest part doesn't really change the CG very much. I hope I explained that properly. That gave an acceptable result, let's say. I had to move the flight controller tray to a different position, probably for the better. I did not move the landing gear, so the wheels are going to be a little bit too far forward than I would prefer, but they are quite heavy and they do a good job of making the nose heavier, so I'll just leave them where they are, even though it might be a little bit harder to lift the tail off the ground when you're trying to take off. So the flight controller tray has moved from inside the fuselage to just in front of the wing on the top, which is probably a more convenient place to have it overall. To cover up all the insides and make the airflow a bit smoother, I made this top cover. The motors have this hexagonal piece at the base of the prop adapter, which is probably for some special props, but it's quite annoying and I don't like the way the prop is sticking out like that. So I filed that off and I threaded the M8 rod down a little bit further. Just doing some tests to see how it can pull itself up this slight slope on the rough grass. On level ground it seems to take just over half throttle to get moving and then about half throttle to keep rolling. To get up that last bit of hill there it takes about 80% throttle. So actually have differential thrust set up too, so if I yaw to the left I just get one motor for a while. And I managed to set up flaperons with a slow slew rate as well, which actually wasn't supported out of the box in ArduPilot. I thought it would be. It was for normal flaps, but for flaperons where the roll is mixed into the flaps I had to do a little bit of changing to the source code. So what I have now seems to work alright. So that's to mid flaps. and fill flaps. Fill flaps, only one of them will move, and then I'll switch it to come back up, and as it comes back up, you'll see I can do flaps while that slow slew is still going. So I'm not sure if I did it correctly, but I might make a pull request to the RG Pilot source code to get that in there to the main branch. Let's try a little bit of full throttle, and I have to keep the rudder under control when I do this as well, because it likes to spin around to the left if I don't. Oh shit. A little bit too much to the right there. That's funny, last time I tried it, it went to the left too much. Okay, that's a bit better. Right, so hopefully I can keep it straight here. Yeah, it's a bit hard to see on camera, but there's a vertical climb of about 4 meters or so to get to the fence there. Right, that was full throttle for the last little bit, but it pulled itself up there, alright. So what does that prove? Nothing much. I just thought it'd be fun to try. Wow, it's surprisingly effective. This is at about half throttle, and I can feel it.
Well, all that bouncing around on the lawn has uncovered the fact that this tail skid here, as I suspected, it's just not really up to the job, so it just sort of cracked in the middle there. So I went back to this design that I sort of made a plastic version of before. Now I tried it with aluminium, and I should have just tried this before because it didn't take very long. I just put this in the vise and bent it around and drilled some holes, and it's very solid in that up and down dimension. Not quite as solid in the side to side, but solid enough. But more of a problem is the fact that even though it turns nice and freely when there's no weight on it like this, as soon as you put a little bit of weight on it and you try and turn it some way or another, it's just not having any of it. And you're probably thinking that it doesn't have enough of a rake going back. This angle is a little bit too shallow, and that could be part of it, but also I think the problem is that I'm just using a screw in the middle there as the pivot point, and I think the thread on the screw is not really helping it. So as soon as any sideways force comes onto there, it just sort of locks up and you can't turn it. So I think this would be more of a liability than a help, because just imagine if you're flying along and when the weight is off the wheel, it's the vibrations of the plane or the wind or whatever turns it that way, and then you try to land and all of a sudden the pivot will lock up, and instead of being able to go like that, it's just going to go whoop across to the side, and you'll probably ground loop or something like that, I guess. So I was a bit puzzled what to do, but then I realised that I could make something much simpler, and as it happens, 5 grams lighter than this, believe it or not. And it doesn't need any screws or bolts or anything to attach it to, and it will take care of one of the problems that I was sort of worried about with this one, which is that the bottom of this wears away, not on grass, but on concrete and gravel it will. So I was actually thinking of putting a little bit of aluminium or something on the bottom of that one, but this solves the problem quite nicely. It's just a teaspoon bent around and glued to this 6mm wrapped carbon fibre rod, which is fairly thick. It's not a thin one. I don't know if you can see it very well there, but the way this attaches to the tail is very simple. Just drilled a hole and made sure that the angle of the hole is actually going to, when it goes all the way in, it's going to hit up against something solid there. And then, I can't do it with one hand, but it's just going to shove in there. It's very difficult to shove it in, but that means it's going to sit there nice and solid. And yeah, it's not as springy as the other one, which is a bit of a pity. It's a little bit solid. It's a little bit too solid, rather. Oh, I can kind of get it in a bit. Anyway, yeah, so I'm quite pleased with that. So 5 grams lighter on the tail, and I made it quite long. I didn't cut the handle off this teaspoon like I thought I might originally, but I wanted to make sure it's nice to have a bit of steel going up here so that you don't scrape the carbon at any point. because on gravel, on soft gravel or deep gravel, the stones could be coming sort of all the way up to here in some places, but the other reason was because I wanted to have a nice long connection for the epoxy to make sure they're going to be stuck together nice and solid. And there is just one problem with this setup, which I did foresee, don't worry, I'm not completely stupid, and that is that when you're in really long grass like this, see it's kind of sunk right in there, the front edges of the spoon there as it moves forward, they're trying to cut through the grass really, rather than slide along on top of it. So it takes a lot more throttle to get rolling, like about 80%. Oh, okay, maybe not too much. It was only about 60 or 70, but in general it's a lot harder to get it rolling than it was before. But once it starts rolling, it seems to be about the same. So on any grass that's not quite as long as my lawn tends to be, or on concrete or gravel, I think it'll be fine. These aileron linkages here I made out of M3 threaded rod. This is not really ideal because the thread is all going the same way, the full length of the rod. Normally you'd have a thread going clockwise on one end and counterclockwise on the other end so that you could just turn the rod to shorten or lengthen the connection. The other problem I've had is they're both M3, these pieces that I'm using here, but the thread doesn't match up very well, so there's a slight bit of play in this direction, and due to my not quite knowing how long that I needed these to be, I've made one of them, this one here in particular, quite short, so that not much of the thread is going into there and it's wobbling around quite a lot, and I don't like that, but fortunately I do have this other thread here, one left. So what I thought I might do is just use some nylock locking nuts, and now that I know how long it needs to be, I can make it so that on one end the threaded rod is just jammed all the way in, and that makes a nice solid connection that doesn't wobble around, and on the other end I can make it a little bit longer than it is already, and also use one of these lock nuts to jam it up against the other end, and probably this end as well, maybe 2 lock nuts, and hopefully that'll make a nice solid rod of just the right length. So just to give you an overview of how the wing mounting setup has changed, originally the front and rear center sections, so that's the aluminium channel here at the front and the rear half angle here, which I don't have on there at the moment, they were sitting here and here, and they were more or less permanently attached there by means of screws, so I was using this screw hole there, and the wings were to be attached one at a time from each side, and that was not really such a great situation because this screw hole here introduced a weakness there exactly where the strength is needed the most. So what I've done, and because I also needed to move the wing back 4 centimeters, which kind of helped a little bit to do this, I've strengthened this section here because that piece of wood there was a bit weak, and this hole here is going to be reused. It's just going to hold on the flight controller tray there, and I've put in another piece back here for the rear spar to sit on, and you'll notice a couple of bits of wood stuck here and here, and another piece of wood stuck here underneath this, and if we look underneath that piece of wood, there's also aluminium reinforcing just at the ends of that piece there. So instead of attaching the wings one by one, what's going to happen is the wings will be assembled onto the center section over here. So the wings will be attached to each other first, and then that whole section, it's very easy to pick up actually, just one screw like that and another one there on the other side, and you can just pick the whole thing up and carry it around, and it doesn't wobble or fall apart or anything. And then that will be placed, let me just demonstrate that. So these wooden sections here are mainly just to help it sort of slot in there in the right place, and then the back will be screwed down, so underneath there's some nut plates with threaded nut plates, so you can just screw straight down. You don't have to get in behind there and hold a nut or anything like that. Now these ones here will be held on by these slightly larger U-bolts, which are also square. I didn't realise they had these ones, but they're much more convenient being a little bit longer. So what these will do and you'll notice there's an eye bolt down the bottom connected by some steel cable to this. These will go up and they will bolt, so they're long enough to go like that, which is just over the top of that channel, and it's actually going to be going through this piece here, which has been carefully slotted into the main wing spar itself. And you see the pencil line at the bottom there, that is where the channel comes up to. So when the bolts tighten down on this U-bolt, that plate is going to be pressing the spar into the center section, and then it's going to be pressing the center section and the spar together onto this beam underneath. So there's no hole drilled here, so no weakness introduced like I had with this hole before, and the section where it's being pressed onto is reinforced by aluminium up to where we have these gussets of plywood here. So I'm hoping that that should be enough. There's another gusset there, and then the piece down the bottom here is intended to transfer that load if the wing suddenly gets thrust upward by doing a loop or something like that. I was a little bit worried that the only beam that's taking that load is this one here. So as well as being slightly sheared to the other side now, it's also going to be sheared directly down to this one, which has been reinforced with a bit of aluminium, and this eye bolt goes through. This is an angle, of course, so there's a flat slab of aluminium along the bottom, and this will be tightened. There's a lock nut on the bottom of this eye bolt, and this will be tightened to make it sort of just a little bit tight, so that the force will not just be taken by this, it will be taken by both of these at the same time. So hopefully that will be a lot more robust than what I had before. The only thing I don't like too much about this setup is that this cable is going to be coming right across the middle here, exactly where you want to put the battery in. I'm still slightly optimistic that even with this cable here, it might be possible to get the batteries in and around, because they're going to have to go up to the front here like that. But if it's not possible, it's not such a big deal just to undo that nut at the bottom and let this eye bolt come up so that the cable will be, you can get the cable right out of the way to put the battery in, and then just put this eye bolt back in and tighten it again. It's probably what I'm going to have to do, I think. Well, the last of the parts that I've been waiting for has finally arrived, so I have no excuses not to get on and finish this project now. The last of the parts that I was waiting for are these little screws here, so I can finally put the wing skin on. My original plan was to use these slightly larger screws here, as I showed you in my first video, and they were just something that I could conveniently buy locally at the hardware store, but they're fairly large diameter. They're about 3mm, and they have a countersunk head on them, which is not the end of the world, but when you screw them in, they sort of make a dimple in the surface, which is not really ideal. So what I did was I found these other screws on Hobby King, which are, these are 2.3mm, and they have a big flat, almost like a washer head on them, so I thought I'd use those. But I think what I might do is use these other ones. These are 2mm, and they have no flat head on them, but that should be enough. And I've been doing a little bit of testing here, and I like these a lot better than the larger screws because they're shorter, well, they're lighter as well, they're smaller, and they're shorter, they don't go through so far, and they make less of a mess of the wood when you take them out. There's still quite a substantial part of the wood remaining versus these ones, which take out quite a bit of it. They sort of push a lot of the wood aside, which is not very good in such a thin piece. But yeah, they stick on really, really well. I just have these 6 screws on here to test, and it ain't going anywhere. So I really hope that when the skin is on, this is going to reduce a lot of the twist that is still present in the wing. It's very easy. If you grab the end of the wing, you can twist it like that, but this should add a lot of diagonal support. So that's all of them there. I ordered a ton of them, I think about 800 in total, but they're pretty cheap though, so not a big deal. But I really like the idea of having a lot of smaller connections to the stringers than having larger connections like I would have had with these larger screws, because that's kind of the way that a full-size plane does it. And even though the sideways force on these, like if you pull sideways, a smaller diameter screw is more likely to start ripping. I think the fact that there's more of them and that load is spread across more individual points should be beneficial overall. I'm just getting started on this middle cover just to get the hang of how to do this. I painted up another sheet of this a couple of weeks ago so it's nice and cured, and I think what I might do is just super glue it like that to begin with, and then put the screws in from the other side on this first piece, and then I can pull it nice and tight and roll it over like that and glue the next bit down, and then put the screws in and so on, and work my way to the back like that. And then to see where to put the screws you need to use a light from the back. So hopefully this will work for the two layers when I'm doing the wing, because I won't be able to put the light inside like I'm doing now. Well, I hate to say it, but it's not going very smoothly so far. The main problem is that these screws are not very sharp. They don't have a nice pointy tip on them, so you have to press quite hard to get it to bite in. And usually what happens is I press and the screw just sort of slips like that and I have to start again. And it seems to be made worse by this enamel on here, which, if anything, is making the surface a little bit tougher to get through with the point of the screw. So what I'm going to have to do is get my little 1mm drill out, and everywhere I want to put a screw I'm going to have to drill a little hole like this before I put the screw in. On the other hand, that does make a very, very easy screw insertion, and it's not going to affect the bite of the screw, because there's still plenty of thickness of screw that's going in there that's going to sort of give a firm, solid connection. So the result will be the same, but it's going to be a hell of a lot more work to cover these wings, that's all.
I want this front edge of the top cover to fit around that kind of tight curve there. So I'm going to try hitting it with the hot air gun and just sort of rolling it on this wooden dowel and see how that goes. Just did a quick test on this, a little offcut, because I was worried that the heat might start to do something funny to the enamel, especially when I press it against the wood to get it to bend, but seems to be perfectly fine. Look at that, no problems at all.
Okay, that's that done. Unfortunately, it did not really turn out how I wanted it to. It's kind of got all bumpy along the front, and I think the problem was that I put this stupid fancy-ass little curve right at the tip here. The idea with that curve was that it was supposed to meet flush with the top of this top panel there, but if I had have just made that curve go straight down, that would have been a lot easier and I wouldn't have ended up with that bumpy look, I think. So I don't think I explained how this fits on, but there's a couple of carbon strips stuck on at the front like that, and they go into these little slots in these little bits of wood that are stuck there and there. And at the rear I have magnets on there, and there are magnets at the back there which will hold that down. The magnets don't actually touch, but because they're both magnets, instead of just one side being a magnet and the other side being metal, it's still quite strong. Plus it's not actually necessary. Could probably get away without the magnets, but this just sort of makes it all much more secure. So it just slides on like that, and to fit it on, this arch, this arch here actually turned out to be very helpful in guiding it. So I just push it back a little bit, and then it slips down on that arch. Push it back a little bit further, and that's it. So it's on there nice and solid. Probably not. I can sort of lift it up a bit at the back if I try, but that should be alright, because the air, it's just air. It's just a cover. It's not necessary to make the plane fly or anything. It just makes it look a bit nicer. And this is a bit flappy here, but I think I'll maybe put another. Oops, sorry, can you see that? There. I might just put another little bit of carbon strip on the back here, so that the trailing edge of this thing can just sort of slide under it instead of being flapping in the breeze like that.
I wanted the receiver antennas to stick out from the bottom of the plane, but I also wanted to be able to put it down on the bench to work on it, so I came up with this arrangement where they sort of fold out from the bottom like this.